So we're coming to the end of the section. The last part of the section is about using lines to model information or to model situations. We call it using lines to model data. And here the situation is dear to my heart because I buy dirt for my garden. It says buying dirt by the ton. The cost is $75 for delivery plus $36 per ton of dirt. So that means if you were to buy 1 ton, you pay $36 for the ton and $75 for delivery, and 36 plus 75 is 111. It is. If you were to buy 2 tons, it'd be 75 to 36 times 2. That's 72. 72 plus 75 is 147. And so on. 5 tons, hope I can do this. This 255 should be 5 of these. 5 times 36 is 180. And 180 plus 75 is 255. So it looks like those calculations might be right. And over here I have a place for the graph. We're going to graph the data. And we're going to use tons on the horizontal axis and dollars on the vertical axis like that. So we go 1, 111, be about here. 2, 147. There. 3, 183. Okay. 4, 219. I'm in trouble. 5, 255. Maybe like that. So I'm thinking that seems to be a linear pattern, like that. So we ought to be able to write the equation of the line. We use that line to predict the cost rather than just looking up there and trying to figure it out. So first we need the slope. So we'll just take 2 points. We'll take this one here and this one here. So that's 1, 1, 1, 1. And this is 5, 255. But you can pick any 2 points. So m is y2 minus y1 over x2 minus x1. So this is point 1, say, and this is point number 2. Okay. So y2 is 255 minus y1 is 111. Okay, and x2 is 5 minus x1 is 1. All right, I'm checking my notes. Since it's 144 on top, looks like it is. 144 over 4, which comes out to be 36. 36 times 4 is 120 plus 24, that's 144. And then to write an equation, we're going to use point slope form. We might be able to use the intercept, but I don't know if they're going to come out to your house and just charge you $75 for doing nothing. Maybe that doesn't make a lot of sense. I wouldn't want to pay it. Just pay them $75 to come and drop off 0 tons. Doesn't make logical sense, but it might make mathematical sense that when the tons is 0, you just pay 75. That could be the intercept. We'll take a point though. Which point do you want to use? One of those points. I guess I'll just use this one. So that's y. Oh, I'm using that point. Okay, 1, 1, 1, 1. And y minus y1 is m x minus x1 like that. That's y minus 111. 36 times x minus 1. That's y minus 111. It's 36x minus 36. That's y equals 36x. I'm going to add 111 to both sides. And 111 plus 36. Turns out to be 75, as predicted. So continuing this on down, it's going to hit the axis here at 75, like as we anticipated. Discussion. Let's see. Could we just guess that that's what was happening? I guess that's the idea. Well, the slope is the increase in y for a unit increase in x. So what's x? X is tons. If you increase your load by 1 ton, it costs you $36 more. So we could just read off from the situation, 36. The intercept might be harder to come by, but on the line, the intercept is the cost when x is 0. I guess you would have guessed, we could have guessed that if 75 is like a fixed cost you pay every time, then the natural extension of the graph ought to be when you hear it's 0, the height should be 75. That should be the intercept. So we could have guessed just from the way it's set up. Anytime you have a situation where you pay a fixed amount plus a cost per unit item that the equation is going to be, the slope is the cost per unit item times the number of items plus the fixed cost. Now we can become entrepreneurs because we know how to price out things that cost a certain amount for each plus some kind of fixed cost, which is a normal way of doing business. And that brings us to the end of the section, and we're ready to get ready for the next section. We'll see you in a while.